Welcome to Spring LIB.
Here we have to answer a couple of questions about the electrolysis of aqueous solutions of sodium sulfate and zinc sulfate. The first question is about the role of sodium sulfate. Basically, why is sodium sulfate added? The answer is the following. When sodium sulfate is added, it undergoes dissociation which yields two sodium cations and one sulfate anion. And these ions improve the ionic conductivity of the electrolyte, and that's why it lowers the resistance of the electrolyte. So, and current can be passed through. The second question is, why is water electrolyzed instead of sodium sulfate? In order to answer this question, we have to first understand which species can be reduced. So, and those species are sodium plus and water. Meanwhile, only water can be oxidized. Because sulfide cannot be oxidized further. So that's why now we need to understand either sodium or water will be reduced when current passes through the system. In order to answer this question, we need to calculate the redox potential of water and sodium. So for sodium, the electrochemical reaction is shown here. So sodium cation receives one electron and forms sodium 0. And the potential of this reaction is negative 2.71 volt versus standard hydrogen electrode. Meanwhile, for the reduction of H plus to H2, the potential can be also calculated. So for this reaction, standard potential equals to the standard potential plus 0.059 multiplied by the logarithm of the activity of hydrogen plus. Or, given the fact that the first term is 0, this equation transforms to negative 0.059 multiplied by the pH. So we need to keep in mind that sodium sulfate has roughly neutral pH. That's why the potential of the couple H plus and H2 equals to negative 0.413 volts, which is above the potential of potential of sodium. So now we can conclude that the potential of the hydrogen redox couple is above the potential of the sodium redox couple. Therefore, water will be reduced. And as I mentioned, sulfate cannot be oxidized further. So no oxidation of sulfate. Therefore, water will be electrolyzed. So the last question, question C, is about the electrolysis of zinc sulfate. So we need to find the time at which 65.5 grams of zinc is formed as a result of the electrolysis. And the current passing through the system equals to 21.0 amperes. So we need to find time in seconds. Let's first start with the electrolysis equation. So zinc 2 plus receives 2 electrons and forms zinc 0. Therefore, the number of moles of zinc equals to 1/2 of number of moles of electrons, or number of moles of electrons equals to double number of moles of zinc. Number of moles of zinc equals to the mass of zinc, formed zinc, divided by the molar mass of zinc. So, or number of electrons equals to the charge divided by the Faraday constant, or time, current multiplied by time divided by F. So now we can complete the system of the equations. So we are going to combine the first equation with the second equation, with the third equation, and with the fourth equation. So when all these four equations are combined, current multiplied by time divided by the Faraday constant equals to 2 multiplied by mass of formed zinc divided by the molar mass of zinc. Or from this equation, time equals to 2 multiplied by the mass of zinc divided by the molar mass of zinc multiplied by the Faraday constant and divided by current. So, or if we put the numbers, so let's finish the calculation. So it equals to 2 multiplied by 65.5 grams multiplied by 96,500 coulombs per mole divided by 65.4 grams per mole and by 21.0 amperes. So it equals to 9,190 seconds.